Start with a moment of reflection. Imagine the vast digital world we rely on every day. Every search query you make, every video you stream, every message you send, and every cloud document you open. Behind all of that lay massive arrays of servers humming in data centers across the globe. These servers are the backbone of the modern internet. They power applications, services, and infrastructures that define how we live, work, and communicate. And yet, very few people ever stop to think about the question that quietly permeates the tech world in 2026. What operating system do these servers actually run on? For decades, a silent revolution has been unfolding in the digital infrastructure of the world's largest technology companies. While the media often highlights flashy product launches, new devices, or AI breakthroughs, a deeper transformation has been underway, one that has its roots in open-source philosophy, economic pressures, and the relentless pursuit of performance and security. That transformation is the shift within tech giants from a mix of proprietary systems and legacy architectures toward a profound reliance on Linux as the dominant operating system for their server infrastructure. In this video, we're going to explore why tech giants are quietly moving their servers to Linux in 2026. Not as a headline-grabbing corporate announcement, but as a strategic, technical, and cultural shift that has consequences across the industry, the open-source ecosystem, and the future of computing. To understand why this shift is occurring, we have to begin with the nature of Linux itself. Linux is an open-source operating system originally created by Linus Torvalds in 1991. Unlike proprietary systems such as Microsoft Windows Server, Linux is freely available, modifiable, and redistributable. What sets it apart is not just that it's free, it's that its source code is open for anyone to inspect, modify, or improve. This has fostered a global community of developers, system architects, and enterprise contributors who continuously refine, secure, and expand the operating system in ways that closed proprietary systems simply cannot match. The first reason tech giants are driving toward Linux is cost efficiency. Licensing fees for proprietary operating systems can be substantial, especially at the scale of thousands or millions of servers. Large enterprises have long sought ways to reduce their total cost of ownership, not just the initial acquisition cost, but ongoing support, licensing renewals, and operational expenses. With Linux, there are no licensing fees. Organizations can deploy and scale their infrastructure without paying per-server software costs. Moreover, because Linux can run efficiently on a wide range of hardware from cutting-edge servers to repurposed older machines, companies can optimize their capital expenditures even further. These financial incentives are a primary reason why Linux adoption continues to grow in enterprise environments with large infrastructure footprints. But cost isn't the whole story. In an age where data breaches and cyber threats dominate headlines, security has become a paramount concern. Linux's open-source nature means that vulnerabilities can be identified and patched by thousands of contributing developers around the world. This accelerates the detection and resolution of potential security issues in ways that proprietary systems often cannot match. Additionally, Linux inherently offers strong security fundamentals, such as advanced permission models and powerful built-in security frameworks, making it a natural choice for mission-critical environments where data integrity and uptime are essential. Let's pause here to consider one telling statistic. As of early 2026, an overwhelming majority of the world's top web and cloud servers run on Linux, with figures indicating that more than 90% of public cloud workloads and the vast majority of high-traffic internet servers are built upon Linux-based platforms. This dominance isn't accidental. It reflects decades of evolution where Linux proved itself consistently reliable under the most demanding workloads. Reliability and stability are central to why Linux is so attractive as a server platform. Linux systems can run for years without needing to be rebooted, and they handle concurrency, networking, and resource scheduling with efficiency and consistency. When a tech giant like Google, Amazon, Facebook, or Microsoft designs production systems that must operate 24/7 with near-zero downtime, the underlying operating system must be capable of operating continuously without interruption. Linux's robustness in high-availability environments is a core reason why these companies have invested so heavily in it. Another major factor in this migration is the way Linux enables customization and control. Large technology companies do not operate like small businesses. They do not want a one-size-fits-all solution imposed upon them. They want control over every layer of their infrastructure. They want to optimize kernels, tweak schedulers, tailor networking stacks, and build tools that fit precisely into their service frameworks. Because Linux is open source, these organizations can do exactly that. They can modify the operating system at the kernel level, incorporate experimental schedulers, or deploy custom patches without waiting for a vendor release cycle. A striking recent example of this is seen at Meta, formerly Facebook, where engineers have adopted an experimental low-latency scheduling framework originally developed for gaming platforms and integrated it across their Linux server fleets. This kind of innovation illustrates how open-source flexibility empowers companies to push performance boundaries in ways proprietary vendors simply cannot. This appetite for innovation and performance also ties into the rise of cutting-edge workloads, particularly those related to artificial intelligence, machine learning, and large-scale data processing. Linux's adaptability has made it the platform of choice for running complex distributed systems, containerized applications, and orchestration platforms like Kubernetes. In fact, Linux underpins nearly all major cloud-native technologies, enabling services to be spun up, scaled, and managed dynamically in response to real-time demand. But corporate strategy goes beyond pure technical merit. There's also a cultural and organizational alignment between the philosophy of open source computing and the way modern tech giants operate. Many of these companies contribute to open source projects, fund development, and participate in collaborative standards bodies. Their IT teams are staffed by engineers who grew up in the open source ecosystem, who understand the value of community-driven development, and who prioritize transparency and interoperability. Linux's open model aligns perfectly with these values, creating a positive feedback loop where adoption and contribution reinforce one another. As Linux continues to evolve, there is also a growing ecosystem of enterprise-grade support and services around it. Distributions such as Red Hat Enterprise Linux (RHEL), SUSE Linux Enterprise Server (CELES), and Ubuntu LTS provide hardened releases, long-term support, security patches, and professional assistance for businesses deploying Linux at scale. These enterprise distributions combine the flexibility of open source with the stability and accountability that corporate operators require. Let's also explore how this shift impacts the broader technology landscape. When tech giants standardize on Linux, they drive market investments in related technologies, from cloud platforms to development tools, monitoring solutions, and container technologies. This in turn encourages smaller companies, startups, and even government agencies to adopt similar strategies. As a result, Linux becomes not just the platform of choice for a handful of giants, but the foundation of an entire ecosystem. Another aspect worth considering is how Linux supports emerging hardware architectures. In recent years, heterogeneous computing, where systems leverage specialized processors such as GPUs, TPUs, and ARM-based servers, has grown rapidly. Linux's modular structure and wide hardware support make it easier to integrate new technologies and tailor system components for performance gains. This is becoming increasingly important as companies design custom silicon and energy-efficient hardware for their data centers. Linux's adaptability gives it an edge in harnessing these advances. Of course, this migration toward Linux is not without challenges. Migrating decades-old systems, retooling legacy applications, and training IT staff to operate efficiently in a new environment are organizational hurdles that require investment. Companies must also build or integrate new management, automation, and orchestration platforms to fully exploit Linux's potential. However, for most tech giants, these upfront investments are outweighed by long-term gains in performance, flexibility, and strategic control. We should also consider the impact of security and compliance, especially in sectors such as finance, healthcare, and government services. Linux's strong security track record means companies can more easily satisfy regulatory requirements and implement advanced auditing, access controls, and encryption measures. This is particularly valuable in an era of stringent data protection laws and escalating cyber threats. Looking at the broader market trends in 2026, Linux doesn't just dominate in the traditional server domain, it powers the majority of cloud workloads and runs on virtually all high-performance computing platforms. More than 70% of Fortune 500 companies run mission-critical workloads on Linux. This dominance suggests a fundamental truth: Linux has become the standard for modern infrastructure at scale. Another often overlooked but important element here is the role of developer ecosystems and tooling. Many modern development frameworks, continuous integration pipelines, container technologies such as Docker and Kubernetes, and observability tools are first built for or optimized on Linux environments. Developers find it easier to test, deploy, and iterate on systems that mirror production environments, and Linux provides a consistent and predictable platform for these workflows. This reduces friction in development cycles and accelerates time to market for new services. As Linux continues to evolve with each kernel release, incorporating optimizations for performance, security, and power efficiency, tech giants are increasingly contributing innovations back into the upstream project. This collaborative cycle benefits not just the largest players, but also smaller organizations and individual developers around the world. So where does all of this lead? By 2026, the quiet migration of server infrastructure to Linux among tech giants isn't just a trend, it's an affirmation of principles that have guided the IT world for decades. Open innovation, cost-effective scaling, robust security, and technological adaptability. Linux has become the default operating system for large-scale infrastructure because it offers a combination of features that proprietary systems struggle to match. In closing, if you walk into any modern data center, cloud region, or server farm that supports the digital services of billions of people, you will almost certainly find servers running Linux at their core. That quiet dominance speaks not just to technical excellence, but to a shift in how the industry builds, sustains, and evolves digital infrastructure. From cost savings to performance gains, from security to openness, from community collaboration to enterprise deployment, Linux has become the invisible hero of the server world. Thank you for watching, and if you found this exploration insightful, consider exploring the wider world of open source computing and how it's shaping our digital future.